Have you ever wondered how computers understand text? When you type hello on your screen, how does your computer store and display it? The answer lies in character encoding, and today we will explore two major systems, ASCII and Unicode. We all know that computers only understand binary zeros and ones, and they don't understand decimals. So therefore, text character like A, B, C, or emojis, when we type in our keyboard, need to be converted into numbers before storage in the computer's disk. Therefore, there are two major encoding standards, ASCII and Unicode. We'll talk about ASCII and Unicode in this video. Now we'll talk about character encoding. So, computers don't understand letters like humans do. They only work with the binary digits zeros and ones. So every characters we type must be converted into a numeric code that computers can process. This process is called character encoding. It maps characters to numbers. So every letter, number and symbol has a unique numeric code. Encoding maps characters to numbers. And these numbers should be stored in the computer disk in the binary form, and decoding converts these binary numbers back to characters. For example, the letter A is 65 in ASCII. Similarly, the emojis have uh, different uh, different Unicode in the Unicode. Now I'll talk about ASCII, the foundation of text encoding. So the full form of ASCII is American Standard Code for Information Interchange, which was developed in 1960 as a way to represent characters in computers. It uses 7-bit characters, allowing it to store 128 different characters. As 2 to the power 7 is 128, so there are 128 characters from 0 to 127. This includes uppercase and lowercase English letters, and also numbers from 0 to 9 and some special symbols. For example, ASCII code of A is 65, which is 1 then 50 followed by 1 1 in binary, and small a is 97 in ASCII, which is 1 1 0 0 0 0 then 1 in binary. There is a fun fact also that the first ever message sent over ARPANET, which was the early internet in 1969, was in ASCII format. It was supposed to be login by the message, but the system crashed after sending just low. So technically, the first word sent on the internet was just low, like it was saying hello. Now we'll talk about ASCII limitations. What was the problem with ASCII? Why we needed more? So ASCII worked well for early computers, but it had a major problem. It could only represent English characters. What if we wanted to type hello in Chinese or bonjour with accented letters? ASCII had no way to store them. Also, ASCII had no emojis, currency symbol like rupee, euro, or dollar, or special characters, which led to the development of Unicode. Now we'll talk about Unicode, which is a universal solution. So what is Unicode? Unicode was introduced to support all languages, symbols and emojis. It is universal character encoding standard that assigns a unique number to every character, no matter what language or script it is. It uses variable length encoding. There are three types of Unicoding: UTF-8, UTF-16 and UTF-32. Since there is variable length encoding, Unicode can use up to 32 bits per character, unlike ASCII, which use just 7 bits per system. So, meaning that Unicode can store over 1.1 million characters. It is also backward compatible with ASCII. That is, first 28 characters in the Unicode are same as that of ASCII. There are also some of the examples of the Unicode encoding for capital A, small a, and the emojis. You can see that capital A is 0041 in U plus, and small a is similarly 1F60A. And this emoji has Unicode encoding of 1F60A. Now I'll talk about Unicode encodings, UTF-8, UTF-16 and UTF-32. Now Unicode itself is just a character set, but we need encodings to store it in memory. The most popular ones are UTF-8, the most common and web standard. It uses 1 to 4 bytes per characters. 1 byte is 8 bits, so it uses 8 bit to 32 bits per characters. It is backward compatible with ASCII, and it is also efficient for English and other common language. Then we have UTF-16, which is used in Windows and Java. It uses 2 to 4 bytes, that is 8 to 16 bits per character. It is good for Asian scripts but less common today. Then we have UTF-32, fixed length but inefficient. That is, in this the number of bits per character is fixed. That is uses 4 bytes per character. That is 32 bits per character. It wasted space for English text but simplifies indexing. So most modern system uses UTF-8 including websites, databases and programming languages like Python and JavaScript. Now we'll compare ASCII and Unicode. So we'll start with the features like characters, language, and size per character and emojis support. So in ASCII there are 128 characters, but in Unicode UTF-8, since it uses 8 bit to 32 bits per character, so 32 bits can relate to 32, which is more than 1.1 million characters in Unicode. Then ASCII is just compatible with English language, but Unicode is compatible with all types of language. In ASCII, since ASCII uses fixed 7 bits for per characters, but Unicode number of characters is not fixed for each number of bits is not fixed for each character. Number of bits can range from 8 to 32 bits per characters. ASCII do not support emojis, while Unicode has character encoding for also emojis. So we can write emojis in Unicode, but earlier ASCII, the computers which use ASCII encoding cannot support emoji. Now we'll talk about real world applications. Where do we use ASCII and Unicode in real life? So ASCII is used in old programming languages, text files, and simple system, while Unicode UTF-8 is used in web development, databases, messaging apps, and modern programming. For example, if your website doesn't use UTF-8 to support, um, it might display question mark, question mark, question mark instead of correct characters. There is also a fun fact that over 95% of all the web pages today use UTF-8 encoding. That means the text on your favorite websites, apps, and games is most likely stored in Unicode. So if you are watching this video, there is a 95% chance the text on your screen is in UTF-8 encoding. Now we come to the conclusion. To sum up, ASCII was simple but limited. Unicode is universal and the best choice for modern computing. So always use UTF-8 when working with text in software, websites or databases. There is one more fun fact. Even though ASCII is outdated for text, people still use it for ASCII as a art. This is an example of ASCII art. So that's all about the ASCII and Unicode encoding. So if you learned something from this video or liked it, then please subscribe and comment. And you can also comment it on what you want to see on the next. Like, do you want to see how emojis are encoded in Unicode or anything? You can comment on that. I'll see that all and decide whether I should make video on that or not. Thank you. Have a nice day.